Thanks, guys. I'm sorry about that interruption. But again, if I have 5 things to choose from, okay, but I'm only choosing 3 of them, the way I find that number is, you know what? This is going to happen for me. The way I choose that is 5 factorial over 5 minus 3 factorial. Okay, that will tell me how many different possible orders there are out of those 5 people for 1, 2, and 3. Okay, so let's look at this. Let me see. I'm going to extend this a bit, and I'm going to write this as 5 factorial over 2 factorial. Okay, because I did 5 minus 3 to get the 2 factorial. Now you're going to remember that 5 factorial, or 5 with the exclamation point, means 5 times 4 times 3 times 2 times 1. And 2 factorial just means 2 times 1. Now before I multiply, I can cancel out anything that shows up on the top and the bottom. So I'm going to cancel out the 1s and the 2s, and I get 5 times 4 times 3, and that equals, oh, not 20, it equals 60. So there are 60 possible ways to take 5 people and choose 3 of them in different orders and to put them in different orders. Okay? Now let me stop for a second because we have a second. Any questions about that? I mean, is anything popping off that you're wondering about? Do you understand the difference between combination and permutation, Benny? Okay. Permutation means order. So if I had Jackson and Ian, that's one combination, right? Just those 2 guys. But if order matters, there are 2 possible orders. It could be Jackson then Ian, or Ian then Jackson. Okay? So permutation is when we give different orders, and combination is just a grouping, how many different groupings there are. Okay? Quickly, CB.
When you did the big P and then the 5 and the 3.
Yes.
Why did you put the 5 on top of the fraction, the 5 factorial on top of the fraction, and not the 3 factorial?
Okay. What CB asked was, why does the 5 go up here and the 5 minus 3 down here? I want you to look back at your notes, and you can look at this little formula. Okay? The number on the left, the number that we're choosing from, goes on top, 5 factorial. Okay? And then the number on the bottom is the number we're choosing from minus the number that we're getting, that we are choosing. So I had a group of 5, but I was only choosing 3 of them. Okay? Choosing 3 from 5. So I do 5 minus 3, and that leaves me with 2 factorial. Then I just write that out and cancel them out. Okay? So that's a formula that we're going to be using today. Ruben.
Does 5 factorial always equal 5 times 4 times 3 times 2?
It does. Ruben's question was, does 5 factorial always equal 5 times 4 times 3 times 2 times 1? It does. And that always comes out to 120 if you just multiply that straight out. The reason we get 60 here is because we divided by 2 on the bottom. Okay? Yeah, Devin.
Why does 0 factorial equal 1?
You know what? 0 factorial, there's a good proof for it, but it's very long. And I usually do it with my advanced algebra class, but I'm not going to do it with you guys. All right? You're going to have to accept that 0 factorial equals 1. All right? Max.
So 2 factorial would be 2 times 1?
2 factorial is 2 times 1. All right? Troy, last one.
And 300 factorial would be like 299.
Good question. 300 factorial would equal 300 times 299 times 298 times 297, all the way down to 1. Okay, that'd be a huge number, obviously. Okay, but that's what 300 factorial would mean. All right, good job, guys.